let's go through the formal definition of an ellipse. So, an ellipse is a set of all points where the sum of the distance between a point P on the ellipse and two fixed points inside of the ellipse is a constant. Okay. Each of those two fixed points is a focus or a focal point for the ellipse. All right, so a singular point is a focus or a focal point. The plural of that is pronounced foci. That's the word you see over here, foci. All right. The center of an ellipse is the midpoint of the segment connecting the two foci. All right, connecting those two focal points. The major axis contains the foci and is the longer of the two axes. All right, it's the longer axis. The other axis, the shorter one, is the minor axis. Okay, the endpoints of the major and minor axes are the vertices of the ellipse. Okay, so those are all of our vocab terms. So now let's get into some diagrams. Let's take a look at a vertical ellipse. The vertices on the major axis are A units from the center, making the major axis 2A units long. So looking at this particular picture, this axis right here is the longer of the two axes. So this is the major axis. And actually, the major axis will start and stop at these vertices. So this is a vertex, and this is a vertex. This distance here is A units long. This distance here is also A units long. So this line segment connecting the two vertices right here is 2A units long. Okay, so that's the major axis. It's the longer of the two. Then we have the minor axis. The minor axis, goes this way. It's perpendicular to the major axis, all right? Those vertices are right here and right here, two vertices. And those distances are B units from the center, making the entire major axis 2B units long, right? The focus points, which are the two black dots that were provided to us, those are C units from the center. Okay, those are C units from the center, all right? Okay, now let's take another look at the same diagram, but a little less clutter. Let's go back to the original here. So now let's tie the definition to the actual ellipse. Now you saw in the other video how this ellipse was created using the two focus points and a piece of string and a marker. All right, we know by definition that the sum of the distances from a point to the two different focus points is going to be a total of 2A. It's a fixed distance, okay? So we've got our focus points. I'm going to call this F1 and F2 for focus point 1 and focus point 2. All right, so those are my foci. Now I'm going to pick an arbitrary point somewhere on the ellipse. Let's put it right here. We're going to call that point P, all right? And what we're saying is the distance from the focus to the point back to the other focus, that distance, if I call this one D1 and this one D2, those two different line segments, the sum of those distances, D1 plus D2, has to be the same as the length as the major axis, 2A, right? And the reason for that is this. If I were to take that point and say, put it right here, well, we know this distance is A, and this is A minus C. And we know this distance is C, and this is another A minus C. And if I work on putting those pieces together, I basically have A here, plus C, but then I have the additional, this part will get covered twice. And that's how I eventually get to 2A, all right? Don't worry about that too much. This is the piece that you need to know, okay? This is the piece that you need to know. All right, let me get rid of all these extra scribbles that I have here. There we go. Oh, don't need those either. Okay. Now we can use this information to generate a formula in order to figure out the relationship between point A, the values, sorry, not the points, the values of A, B, and C. We're going to do this by relocating point P to be at a vertex along the minor axis just to make the computations a little bit easier. You'll see how this formula comes to be in the next video. I'll catch you there.